Hey guys, I wanted to do just a really brief, quick update, just a general update on the whole state of things. And the last time I really went over everything that I had going on, it was because everything was a little bit broken. All because of that. Okay, so I blame that battery. It's not the battery's fault, it's my fault. But I'm still blaming the battery. The battery blew up, and not as spectacularly as some others. Now, this is something that I always try to enforce, or not enforce, to remind people. See that up there? Let's see if I can get zoomed in. I leave that up there as a little bit of a trophy. There's that chunk that's stuck in the ceiling of my shop. That was a battery that really blew up. And I actually have another one over here. This is 22 feet away. And that is about the size of a $50. I don't know what I could compare it to for anybody else out there who do not have American $50. It's about maybe 2 centimeters across. That flew from this battery bank all the way over there with enough force to stick in the wall. Be nice to your batteries. Don't do like me. Anyway, so that battery blew up, unloaded my system. The turbines freewheeled, voltage went through the roof because all my inverters are tied to the turbines in parallel with the batteries. Whenever the voltage went through the roof, it blew up to my inverters. And that was, at the time, it was this one and this one that it blew up. The ones on this bank over here actually were okay. I now have that one moved to that side. You can see this is one of the ones that blew up. What happened is whenever voltage goes up real high, it blows up these capacitors. And this one, it also took out that MOSFET. None of the other MOSFETs look damaged, but that one's got a big old crack in it. So I think that that's shot. We're going to look at replacing that one. I'm going to take a stab at repairing them, but I've got 2 more coming. If I spend 3 hours trying to fix these things, it's cheaper financially, but it's hard on my time. Right now, our current state of things is I have the Healy 2.0 and the i2000. They're currently running. It's not very windy outside, which is why I can let them run on only this inverter and that inverter. This one's still broken. It's only there as a placeholder right at this moment. But they are up and going. So that part of my system is back up to at least doing something. Here in a moment, I'm going to turn the Healy off because I don't trust that one running out here with just the 2 inverters. Now, something that I have been working on over the last couple of weeks is finding a way to make this work, because basically, as I've discussed in all my other videos, the dump load circuit is always live. Now, every time I post a video where I say that, someone will say, well, have you tried adjusting the voltages, turn the dump load off, whatever, in the settings? I did all that, and it's still just on all the time. And that's because whatever controls the dump load is jacked, and it's been jacked since I got the thing. So what I have been trying to do is operating it with an external brake up here, which is what this assembly is. And these are 1500 watt, 120 volt water heater elements. Putting them in series, no, not series, parallel. I put them parallel. Putting them in parallel like this brings the ohms down to where we need them to be, and it makes each one only really absorb about 450 watts. It is enough to bring the turbines to a stop whenever they are running full tilt. They do get hot, but they don't get so hot as to melt. I'm not worried about them. I don't trust them fully yet, unattended. I'm going to come out and play with them quite a bit before I do that. But basically, I have a voltage switch that will go here. The voltage switch uses this 24 volt transformer to turn this brake on at high voltage. Now you can see a little bit of a problem that I've had there. All that is all of this stuff. So this is something that I'd like to talk about. This is a CD63 voltage controller, battery controller. Now, I really like these A30 controllers. There's only one thing that I don't like about the A30 controllers. Okay, I'll say two things. There's only two things that I don't like about the A30 controllers. One is that once these things get up to about 90 volts, they blow up. Not normally a problem. It's a 48 volt circuit. 90 volts should never happen. That shouldn't be an issue. The only time that it happens is if my batteries blow up, then I lose all my controllers. And that's why, even though I had 4 controllers spread out over here, I now only have 1. And it was the one that was in the box for a spare, because I can't get any others easily because they're all in China. I love the controller. That's the other thing that I don't like about it, and it's the thing that really hangs me up about having extras, is that I have to order it from China. The other option is I can order one from like Missouri Wind for $50. It's a $10 controller. I'm not going to pay a 500% markup to get it from someone who has it in the States. So eBay is covered with these kinds of things. And what I'm seeing a problem with is, for one thing, all of these controllers, they are straight through voltage. This relay all it does is connect the positive on this side to the positive on that side. So you get straight battery voltage across. Now, on a low voltage circuit, if you're using this for a 12 volt turbine, you can use that to turn your relays or your dump load on. It is not going to work for a 24 volt circuit, because that will easily exceed the 32 volts that's normally your trigger voltage on a lot of these solid state relays, and also a lot of these mechanical relays. And they also cap out at 60 volts. Now, this is the thing, is that like this A30 controller says that it will stop at 80 volts, that it goes to 80 volts. But if you run past that 80 volts to about 90 to 95, it'll do it briefly. So you have a little bit of leeway there. This thing says 60 volts, and it damn well means it. At 61 volts, it blows up. So I've actually gone through quite a few of these. And the way now, if you wanted to use it with a lower voltage circuit, and I've actually thought about, that this would apply if I used it as a balancer and used one on each of my battery, rows of batteries, and operated it at 12 volts, then it would work pretty decently. But at 48 volts, no, because I routinely get up to 60 volts on the circuit. Now, I have been bypassing this little connection so I could use the relay part to operate a low voltage circuit. And I did that I removed this relay, and then I tied just a wire to one side. And then I could use this screw terminal and that wire to connect the circuit. But because it blows up at 60 volts, it's trash. Not a good setup for this. So I did go ahead and order some more of these things, but because they're coming from China, it's going to be several weeks before I get them, which means it'll be several weeks before I can get this thing up here to where it's working the way I want it to. Now, with the 60 volt controller, it actually was working. It was doing a good job. It just struggled with that 60 volts. And the way this inverter works, now maybe there's something going on with the software right now, and that's why it's jacked up, or why it's not really feeding properly. But if I tie if I tied my i2000 to it, it was only kicking out like 100, 150 watts. Whereas if I put it on my battery bank, it was making excuse me, it was making like 250 or 300. So this was clamping down on it a little bit too much. And I just thought, well, maybe there's not enough wind. I put my Healy on it, and the Healy just runs away. It can't control the Healy at all. So there's also that. Anyway, so just a little bit of an update, like I said. Nothing super spectacular. I do have, I got more of my battery. I got more of my controllers coming in. I've got 2 more big shiny metal things. Inverters. I got more inverters coming in. And we've got a couple of projects planned for the near future. So hopefully over the next couple of weeks I'll have this back up and working properly. I hope to possibly have a new inverter, big blue inverter coming in. Maybe we can fix this one, maybe not. I'm not really sure. If I get another one of these and I don't have any input off of this thing, I might just run it like I've been running, these things. Run it as a solar inverter, since it'll actually operate off of 48 volt circuit. That's another thing. These things, 45 volts is tops. I have to run them off of 24 volt circuits. So I always have to have 2 of them operating in parallel, one off of each half of the bank. So it can get tricky. Anyway, that's that for now. I've already rambled on too much. If you guys got any comments or questions, I'm always open. And thanks for watching. Hope you all have a very wonderful, hope my hand's not in the way. Hope you all have a wonderful day. Thanks for watching.